In this video, we're going to be talking about computer forensics. So computers have permeated society and are used in countless ways with innumerable applications. They are everywhere. Similarly, the role of electronic data in investigative work has achieved exponential growth in the last decade. Cyber crimes are a huge issue and there are a ton of people out who solve them, but it's a little different than how we've learned to process evidence up until this point. So the use of computers and other electronic data storage devices leave the footprints and data trails of their users. Nothing is really secret on your electronic device. So computer forensics involves the preservation, acquisition, and extraction and interpretation of computer data. In today's world of technology, many devices are capable of storing data and could thus be grouped into the field of computer forensics. So when we're talking about computer forensics, we aren't just actually talking about computers, we are talking about a lot of things. Although later in this unit, we're going to focus on mobile forensics specifically. So some basics. Since I know a lot of you, although you have a lot of electronics, you probably don't know much about them. So the first kind of big terms are hardware versus software. So hardware comprises the physical and tangible components of the computer. So all of the physical parts of your computer. Meanwhile, software is a set of instructions compiled into a program that performs a particular task. Software consists of those programs and applications that carry out a set of instructions on the hardware. For example, Microsoft Office is an example of software. All of those things you download onto a computer are software, while the physical components are hardware. Some other terminology for you is computer case or chassis. This is the physical box holding the fixed internal computer components in place. And power supply, the PC's power supply converts the power it gets from the wall outlet into a usable format for the computer and its components. Another piece of terminology for you is motherboard, and this is the main circuit board contained within a computer or other electronic device. It has a socket to accept RAM and connects to every device used by the system. We'll talk more about RAM later. Another piece of terminology for you is the system bus, and contained on the motherboard is the system bus, and it's a vast complex network of wires that serves to carry data from one hardware device to another. Here is a picture for you. This is a diagram of a personal computer showing the hardware components of the computer. So you can see we have the ROM and the RAM and the computer chassis, the CPU, the external drive, CD, DVD drive, floppy disk drive depending on how old this is, the hard disk drive, sometimes called the HDD, your power supply. So these are all the physical components of a computer. Read-only memory, also known as ROM, is another piece of terminology for you. And these are chips store programs called firmware, which are used to start the boot process and configure a computer's components. So this is what allows your computer to turn on and all of those things it runs when it's turning on. In addition to ROM, we have RAM, which stands for Random Access Memory, and this serves to take the burden off of the computer's processor and the hard disk drive, HDD. The computer, aware that it may need certain data at a moment's notice, stores the data in the RAM. RAM is often referred to as volatile memory because it's not permanent. Its contents undergo constant change and are forever lost once power is taken away from the computer. So it's just shortly storing things there. The central processing unit, also called the CPU, which is also referred to just as the processor, is essentially the brains of the computer. It's telling the computer what to do and when, just like your brain tells your body what to do and when. We also have input devices, and these are devices used to get data into the computer. Some example of input devices are the keyboard, a mouse, if you're a gamer, a joystick, a scanner, a printer, all of these things that we can connect either wirelessly or with wires to our computer. We also have output devices, And this is equipment through which data is obtained from the computer. For example, the monitor, the printer, the speakers, things that are going to put out information. As I previously mentioned, the hard disk drive, which is the HDD, is typically the primary location for data storage within the computer. This is where all of our more long-term data and things we specifically saved are going to be stored. Different operating systems map out, which we refer to as partition, HDDs in different manners, and examiners must be familiar with the file system that they are examining in order to avoid destroying it. Evidence can exist in many different locations and in numerous forms on the HDD. The type of evidence can be grouped under two major subheadings: the visible data and the latent data. So generally speaking, an HDD needs to have its space defined before it's ready to use. So partitioning the HDD is the first step, so separating it out into the different parts. When partitioned, HDDs have mapped, which we also call formatted, and have a defined layout. Most computers come pre-partitioned and pre-formatted, although you sometimes do have to have your computer reformatted if something has gone wrong. HDDs are logically divided into sectors, clusters, tracks, and cylinders. Sectors are typically 512 bytes in size. A byte is 8 bits, and a bit is a single 1 or 0. And this is because bit is actually short for binary digit. That's where the it comes from, meaning ones or zeros. That is the binary. A cluster are a group of sectors, and their size is defined by the operating system. Clusters are always in sector multiples of 2. A cluster, therefore, will consist of 2, 4, 6, 8, and so forth sectors. With modern-day operating systems, the user can exercise some control over the amount of sectors per cluster. Most of us don't do that with our computers, but it is possible. Tracks are concentric circles that are defined around the platter, and cylinders are groups of tracks that reside directly above and below each other. Here is a picture of the partitions of the hard disk drive. You can see the different sectors, those pieces of the pie. The cylinder is the different layers. The track is our different circles, and the shaft is the center column there. So after the partitioning and formatting processes are complete, the HDD will have a map of the layout of the defined space in that partition. Partitions utilize a file allocation table, which is called a FAT, to keep track of the location of files and folders, which are basically data, on the HDD. The NTFS partition, like Windows 7, Windows 8, Windows 10, utilizes, among other things, a master file table, which is called the MTF. Each partition table, a map, tracks data in different ways. The computer forensic examiner should be versed in the technical nuances of the HDDs that they examine. It is sufficient for our purposes here, however, merely to visualize the partition table as a map to where the data is located. It is more complicated than that, but for our purposes, it's going to be fine. This map uses the numbering of sectors, clusters, tracks, and cylinders that we already talked about to keep track of the data partitioning of the HDD. Processing the electronic crime scene has a lot in common with processing a traditional crime scene. The first thing we have to do is we have to get warrants. We cannot search for evidence unless we have a warrant in place. We want to do our proper documentation. You're still going to want to take pictures, all of that stuff we've talked about, and we're still going to use all of those good investigative techniques that we've already learned about. At this point, a decision must be made as to whether a live acquisition of data is necessary, meaning we get it at the crime scene instead of taking those things with us. Several factors are going to influence the systematic shutdown versus the pulling the plug decision. We're not going to go into like everything that would allow you to make that decision, but for example, if encryption is being used, pulling the plug will encrypt the data, rendering it unreadable without a password or key. Therefore, pulling the plug isn't going to be good, so we're going to want to try a systematic shutdown instead. Once again, it really depends on what the computer is doing at the time of the investigation as far as what you're going to want to do. Similarly, if crucial evidentiary data exists in the RAM and has not been saved to the HDD and will thus be lost with the discontinuation of the power to the system, another option must be considered because we don't want to cut the power and lose what is only being temporarily stored on the RAM. Regardless, the equipment is most likely going to be seized. When we're solving computer crimes, they usually take tablets, phones, computers, what is ever being used with them. So now that the items have been seized, they're going to go back to a computer forensics lab for analysis. The computer's HDD, hard disk drive, will be used as an example, but the same best practice principles apply to other electronic devices as well. So we're going to talk about the HDD, but essentially the process would be similar for any electronic device we're talking about. Throughout the entire process, the computer forensics examiner must adopt the method that is least intrusive. The goal of obtaining data from an HDD is to do so without altering even one bit of data. You do not want to change any of the data that you are trying to collect because that may render it invalid. So because booting an HDD to its operating system changes many files, every time you boot your system, it does change some of the files. That means it could potentially destroy evidentiary data. And so attaining the data is generally accomplished by removing the HDD from the system. So they take the computer apart and place it in a laboratory forensic computer so that a forensic image can be created. So we essentially take apart the computer, take the part we want, the HDD, and we're going to put it in a computer that doesn't have an HDD / has another place we can stick one in, so we can take a forensic image of everything that is on that HDD. Occasionally, in cases of specialized or unique equipment or systems, the image of the HDD must be obtained utilizing the seized computer. That you can't get the HDD out or something's happening on it, we can use its own computer to create an image. Regardless, the examiner needs to be able to prove that the forensic image obtained includes every bit of data and results in no changes, writes, to the HDD. To this end, a sort of fingerprint of the drive is taken before and after imaging. We want to make sure to do both. This fingerprint is accomplished through the use of Message Digest 5, MD5, Secure Hash Algorithm, SHA, or a similar validated algorithm. So these are essentially types of computer programs, more or less, that we use to get that data. Before imaging the drive, the algorithm is run and a 32-character alphanumeric string is produced based on the drive's contents. We are getting a kind of written copy of everything that's on the drive's contents. It's then run against the resulting forensic image, and if nothing changed, the same alphanumeric string will be produced, thus demonstrating that the image is all-inclusive of the original contents and nothing was altered in the process. That is why we take one before and after to prove that we have not changed anything. So I mentioned earlier that there were two types of data, visible and latent. So visible data is the data which the operating system is aware. This data is easily and readily accessible to the user. From an evidentiary standpoint, it can encompass any type of user-created data, such as word processing documents. This is actually the most common place to look when trying to find information on a computer. By word processing documents, I mean Word, the program, but any of these kind of text file sort of things, a lot of people type things into those, and it's a great record, especially since most of them automatically save. You can also check spreadsheets, accounting records, databases, pictures, all of those fall under visible data. Meanwhile, temporary files created by programs as sort of a backup on the fly can also prove to be valuable evidence. A lot of your documents, I don't know if you've noticed, if you've ever been working on like a PowerPoint or a Word document, you will notice that it autosaves. And if your computer up and shut down, when you reload it, it tells you it has this autosave file. That is a temporary file that it created. Finally, data in the swap space, which is utilized to conserve valuable RAM within the computer, can yield evidentiary data. Meanwhile, latent data is that data of which the system is kind of unaware of. It's hidden from view. Latent data will not be in temporary files. Temporary files are visible. In this figure, you can see a user switches between applications and performs multiple tasks, and data is swapped back and forth between the RAM and the computer's hard disk drive. This area of the hard disk drive is referred to either as swap space or a paging file. So you can see that it's just a small part on the hard disk drive. A little bit more about latent data. So evidentiary latent data can exist in both the RAM and the file slack. So RAM slack is the area from the end of the logical file to the end of that sector, which we've already talked about sectors. And file slack is the remaining area from the end of the final sector containing the data to the end of the cluster, which we've also talked about both those things already. Another area where latent data might be found is in the unallocated space. An unallocated space is that space on the hard disk drive, the HDD, that the operating system sees as empty and ready to store data. Visible data is not going to be present here. This is a simplistic view of a hard drive platter demonstrating the concept of unallocated space. So you can see in this purple color, this is data occupying the sectors, these different pie pieces, that it's aware of, but then we have this unallocated space near the center in the blue that it is unaware of. So the constant shuffling of data through deletion, defragmentation, swapping, and so on is one of the ways that data can be orphaned in latent areas. Finally, when a user deletes files, the files typically remain behind, and it's retained until the disk space is allocated for another use. So therefore, it may still be found using forensic image acquisition software. So long story short, when you delete something, it's not really deleted, and they can usually find it. So places on a computer where a forensic computer examiner might look to determine what websites a computer user has recently visited. So there's the Internet Cache, which is copies of the most recently requested websites. They might also look at cookies. I'm sure you're used to going to websites and they ask you if you will approve them downloading cookies. So cookies track information about web visitors, like usually so they can personalize ads to you. And then they can also check the Internet History, which is a list of websites recently visited. The history file can be located and read with a forensic software package. Another way to access websites that have been visited is by examining the bookmarks and the favorite places. Once again, we are so used to thinking about criminals as these criminal masterminds that have thought everything through, but there are plenty of times where they have seized someone's computer, and in the Internet History and on the favorite websites is literally like how to murder someone and not get caught. And it's just right there out in the open for them to see. This brings us to IP addresses. So IP addresses provide the means by which data can be routed to the appropriate location, and they also provide the means by which most internet investigations are conducted. So IP addresses take the form number dot number dot number dot number. So it will be 12 numbers, each in groups of 3. In which, generally speaking, the 3 numbers can be any number between 0 and 255. So an investigator tracking the origin of an email seeks the sender's IP address, which is, if it's an email, is actually usually in the header. It's not super difficult to track down. Tracking down the location of that IP address may be a little trickier, but the IP address is there. Chats and instant messages are typically located in the computer's random access memory, so we can also look at those to find the IP address. So tracking the origin of unauthorized computer intrusions, or hacking, requires investigating a computer's log file, RAM, and network traffic. I'm sure you've heard plenty of times people say that they weren't the one that posted that thing online and that they got hacked. Well, they can actually investigate whether you were in fact hacked or not. One of the best ways to prevent hacking is a firewall, which is a device designed to protect against intrusions into the computer network. Firewalls and antivirus software used to not be super common on personal computers. However, after so many hacks and so many intrusions, now they are pretty common for all computers to have them already set up. Whew. That was a lot about computer forensics. Highly recommend, if you're confused about any of it, that you watch this over again, because this is a big part of our test.